discuss about the concept of electrostatic potential and capacitance. So in electrostatic potential and capacitance, we have the topics like introduction, electrostatic potential, electrostatic potential due to a point charge, electrostatic potential due to a dipole, potential due to a system of charges, potential energy in an external field, electrostatics of conductors, dielectrics and polarization, capacitors and capacitance, the parallel plate capacitor, the effect of dielectric on capacitance, combination of capacitors, energy stored in a capacitor. These are the topics from electrostatic potential and capacitance. Van de Graaff generator also is there, but that is deleted from the topic, from the syllabus. So, first we see that what is the importance of electrostatic potential, where we use the electrostatic potential and the capacitance, and where we are using the electricity, and there we use the potential, that concept of electric potential will arise. And this potential energy was introduced in work energy power and oscillations. You studied in first PU work energy power and oscillations. In the potential energy concept we discussed. And the potential energy, to understand the potential energy, when an external force taking in a body from a point to the other against the force, like a spring force or gravitational force, the work gets stored as potential energy. When we remove the external force, what happens? The energy gained by the body is kinetic energy. The kinetic energy which is equals to the loss of potential energy. But the sum of kinetic energy and potential energy is conserved, and such type of forces are called conservative forces. Examples for the conservative forces are spring force and the gravitational force. Already we discussed in first view about the conservative force and examples of conservative forces. Now in this topic we see that Coulomb force. The Coulomb force between two stationary charges is also a conservative force. We know the examples of conservative forces are gravitational force, spring force, and now one more force we got, that Coulombic force. So the Coulombic force between two stationary charges are also conservative, like gravitational force. The gravitational force and the Coulomb force, both of them obeys inverse square law. The main difference is the proportionality constant. And we can define that potential energy, that electrostatic potential energy in electrostatics, like gravitational potential energy in gravitational field. The potential energy is that we need some work to bring the charge from infinity to the given point against the electric field. Because when we take the charge, the stationary charge, we know that the charge can create the electric field. And to bring one more charge, that is test charge, to bring the test charge into the field, given field, electrostatic field, we need to do some work, because electric force acts on the charge, test charge, so we need to do the force, we need to do the work against to the electrostatic field. So we can define potential energy difference also, that is the work required to bring the charge from one point to the another point against the electric field. And here that the conservative force does not depend on the path, it depends only the initial and final points. And this electrostatic potential energy would not be meaningful when it depends on the path. So here the electrostatic field, the conservative force, depends only the initial and final points. And the capacitors, we know about the capacitors, it is a device to store the charge, electrical charge, in the form of energy, electrical energy, in the same way like water stored in a tank. And it depends on the capacity, depends on the shape and size and surroundings of the medium. Okay. So in this chapter we discuss all these topics, subtopics. We have written all the topics and one by one we will discuss. So in that, we have completed introduction, and the second one is the electrostatic potential. So then, what is electrostatic potential? And this electrostatic potential, to understand this electrostatic potential, you take a stationary charge configuration. So in that stationary charge configuration, when we bring the charge, test charge, from infinity to the given point against the electric field, we can say that the work done is proportional to the test charge, so that we can divide the work done by the amount of charge, and the resultant quantity of the test charge is independent, so that here the electrostatic potential can be defined. The work is required. For example, we place the charge at point O. Here the positive charge Q at point O, and this charge can create the field, creates the electric field. Then we want to bring the charge from infinity. So we are going to bring the charge from infinity to the given point against to the electric field is called the electrostatic potential. And this electrostatic potential, we know the symbol of electrostatic potential. electrostatic potential So, the electrostatic potential is the amount of work is required to bring the charge from infinity to the given point. So, here we consider the charge plus Q at point O. And it creates that field. And we want to bring the charge from infinity to the given point B. So we can write that mathematically of the electrostatic potential is that V is equals to work done by the test charge. So here we are doing the work to bring the charge from infinity to the given point to the against to the electric field, and that we call the electrostatic potential. And this electrostatic potential is the scalar quantity. It is a scalar electrostatic potential. V is a scalar quantity. And the units of electrostatic potential are joule per coulomb or volt. The units of electrostatic potential. And the dimensional formula of electrostatic potential. We know that how to write the dimensional formula of the electrostatic potential by taking the fundamental quantities. So here that work done by the charge. Then work done dimensional formula is m L power 2. Dimensional formula of work done is m L power 2 T power minus 2 by a dimensional formula of charge. Dimensional formula of charge is that A into T. So now to write the dimensional formula of the potential is m L power 2 T power minus 3 A power minus 1 is the dimensional formula of the electrostatic potential. And we know here the units of potential we can measure in volts also. Then we can define the volt also. So that is 1 volt is equals to 1 joule by the 1 coulomb. So it means we can define the volt is that the electrostatic potential is said to be 1 volt when 1 joule amount of work is required to bring the 1 coulomb of charge from infinity to the given point is called the volt. And the potential difference, we can define the potential difference also. Now we know about the potential, electrostatic potential. Mathematically we can define that That potential, electrostatic potential is that to bring the charge from infinity to the given point against the electric field and measured in volts, and it is scalar quantity and the units it is we know. And what is potential difference? What is the potential difference? We know potential, then potential difference is that the amount of work is required to bring the charge from one point to the another point. So to understand that potential difference, again we consider the charge at point O, or consider A, and here the positive charge Q. And now we want to know the potential difference, and we consider here the point B and point C. So now that the potential at the point B is VB and potential at the point C is VC, and we use that potential energy UB and UC. These are the potential energies. So here the notation is, we consider the positive charge and it is placed at point A, and we want to know potential difference between B and C. So for that, the notation of VB and VC, UB and UC. So here VB and VC are the potential at the point B. VC is the electrostatic potential at the point C. UB is the electrostatic potential energy at point B. Potential energy at point C. So to know the potential difference, we know potential difference, the amount of work is required to bring the charge from one point to the another point. Suppose we want to bring the charge from point C to point B and further. So now we are going to bring the charge from infinity to the given point C, and the corresponding potential is VC. So from infinity to point C, and from infinity to point B is potential is VB. From the definition, we know clearly here VB is greater than VC. The potential at the point B is greater than the potential at the point C. So the potential difference between B and C. So by the definition of potential difference, that is VBC is equals to VC minus VB between B and C. Then VC minus VB is equals to the corresponding potential energy. Potential energy is that at point C is that UC minus UB divided by the charge Q or Q naught. So here we use the notation for the test charge Q naught. Then the potential difference between B and C means we are going to bring the charge from infinity to point C. The corresponding potential is BC, and we are going to bring the charge from infinity to point B. Then the potential is the BB. So then it is VC minus VB, then is equals to UC minus UB by Q naught. And if you take the potential difference from C to B, because here we are going to bring the charge from point C to point B, VCB, that is equals to VB minus VC is equals to UB minus UC divided by Q naught. Okay, that is the potential difference between B and C. And here that VB is greater than VC, potential at point B is greater than point C. So from this potential difference we can give the important points regarding the potential difference. That first point is that VCB will be positive when it is taking the charge against to the electric field, then the potential difference will be positive. And when you take the charge along the same direction of the electric field, then there is no work, because same direction, then electric field is doing the work. Then potential difference, that VCB will be negative along the same direction. And if the charge is the positive charge, then the electric field is away from the charges, because we know the direction of the electric field and direction of the electrostatic force. If the charges are like charges, then the direction of the electric field will be away from the charges. If the charge is the negative charge, then the direction of the electric field will be along the direction. Say means inside or towards the charge. We can say instead of that, along that, towards the charge. So when the charge is positive, electric field is directed away from the charge. When the charge is negative, the direction of electric field is towards the charge. And one more is that here the positive charge rises the positive potential and the negative charge rises the negative potential. And the potential in terms of the work done, we know that the potential V is equals to W by Q naught. Then work done is equals to V into Q naught. Okay, and this is about the potential, electrostatic potential and the potential difference. And one more, the important points of the potential, electrostatic potential. Earth, if you consider the Earth is the huge reservoir. And if you add some amount of charge or removal of the charge, there is no change in potential of the Earth. So in the important points, note, Earth considered as the huge reservoir, and if you add some amount of charge or if you remove some amount of charge, there is no change in the potential of the Earth, and it is the electrically neutral, and the potential of the Earth taken as the zero. And all the potentials of the the bodies are measured by taking the potential of the earth. That is one of the point. And the second point is that if you take the negative charged body, and this negative charged body is grounded or earthing, then what happens? Here the electrons flow from the body to the earth till the potential of the body is same as the potential of the earth. So then electrons will flow from body to the earth and the current direction will be in opposite. Okay, electrons will flow from body to the earth till the potential should be same as the potential of the earth. So initially the body has the lower potential, the negative charge. We say that negative potential and the lower potential initially. Then after earthing what happens? The electrons flows from the body to the earth till the potential becomes same. Then we consider as the negative potential. And the third one is we consider the positive charged body. And this positive charged body is also under the earth, means earthing. Now what happens? The electrons flow from earth to the body till the potential becomes the same, till the potential of earth and the body should be same. So here the electrons flow from earth to the body, and the current direction will be downward direction. This is the current direction, and initially it has higher potential than the earth, and after earthing and it becomes the higher potential. So our positive potential, and it will be potential and the negative potential. Okay. So one time we recall that what we have discussed, that is introduction about electrostatic potential and the capacitance and the live examples in daily life where we are using the electricity, there the potential will arise. And one more also for the potential, if you compare the potential, how we take the temperature in heat and pressure in hydrostatics. In the electrostatics we have the potential, that electric potential or electrostatic potential is analogy to the temperature in heat and the pressure in hydrostatics. It means pressure difference. If any pressure difference, then water flows from higher level to the lower level. In the same way, when you take the conductors, then because of the electric pressure that we call that potential difference, so due to the potential difference, then flow of electrons. Okay, so that we use in the daily life. And capacitors also we use that. Capacitor is a device to store the charge, electrical charge, and in the form of electrical energy. Okay, and the electrostatic potential. That electrostatic potential is that the amount of work is required. Here W represents the amount of work. Amount of work is required to bring the charge, that is unit positive test charge, or we can call that test charge. Okay, so to bring the test charge from infinity to the given point, so we are taking the charge to the field, means that we need to do work against the field. Okay, that is called the potential. And this electrostatic potential is equal to the potential energy per unit test charge. So that potential is W by, the mathematical form of potential is the W by Q naught, and it is a scalar quantity, and the units are joule per coulomb or volt. And the potential dimensional formula is L power 2 T power minus 3 A power minus 1. And from this definition of electrostatic potential, we can define the volt. The electrostatic potential is said to be 1 volt when 1 joule amount of work is required to bring 1 coulomb of charge from infinity to the given point, then potential is said to be 1 volt. And the potential difference, we want to take the potential difference, we want to know the potential difference between point B and C. So we consider one charge, positive charge, and it is placed at A, and we bring the charge from infinity to point C. The corresponding potential is Vc and the potential energy is Uc. And from infinity to the point B, the potential, electrostatic potential is Vb, and the potential energy is that Ub. Then potential difference between B and C is that Vb minus Vc, that is equals to potential energy difference, that is Ub minus Uc divided by Q naught. So here Q naught represents the positive test charge, unit positive test charge. If Vb is greater than Vc, potential at point B is greater than potential at point C, and it will be positive when we are taking the charge against to the field, electric field, and in moving charge, that is from B to C, then there is no need of work because electric field is doing work. Then the potential difference will be negative, and work done for the potential difference is the product of the electrostatic potential and the charge, test charge Q naught. And the important points regarding the potential. The earth considered as huge reservoir. So when it is huge reservoir, when we remove some amount of charge or when we add some amount of charge, there is no change in potential. Like when we compare with the water, the sea water. So when we take some water from the sea, there is no change in amount of water. And if we add some water in the sea, and again there is no change. In the same way, when we add some amount of charge to the earth or when we remove some amount of charge from the earth, there is no change in potential. So the earth is electrically neutral and the potential is taken as 0, and all the potentials of the bodies can be measured by taking the potential of earth. And when you take the negative charged body, and the negative charged body is earthing, then the electrons flow from body to the earth till the potential becomes same. And when you take the positive charged body, the electrons flow from earth to the body till the potential becomes same. Okay, this is about the potential, electrostatic potential.